Hello, and welcome to the So You Want to Be a Marine Biologist podcast, where we learn about the ocean, share sea stories, and explore ocean careers. I'm your host, Kara Muzia. Let's dive into today's episode. This episode is brought to you by the Safina Center. Through best-selling and award-winning books, films, and photography, the Safina Center is making a case for life on Earth. Founded by Carl Safina, award-winning author and ecologist in 2003, the Safina Center aims to inspire and engage to devote time and energies to conservation of wild things and wild places. If you haven't already, check out episode 22 of this podcast. On it, I chat with Carl Safina about his lifetime of conservation work and how the Safina Center came to be. I've personally been inspired by Carl and the work of the Safina Center. Their work brings wildlife in all its forms into our homes and hearts and makes the case for preserving this beautiful planet of ours. For more information, please visit safinacenter.org. Hey, do you want to help the oceans? Have you considered a career in marine biology, but maybe just aren't sure where to start? Head on over to my website, marinebio.life, and subscribe to my newsletter. When you subscribe, you'll receive a free PDF download where you'll learn the 7 steps to becoming a marine biologist without the degree. Hello, mermaids, pirates, ocean lovers, and land lubbers. Welcome to today's show. Today, we are chatting with Maria Pinto, marine biologist and founder of the Sea and Me Marine Stuff with Maria YouTube channel. Today, we're diving into how growing up in coastal Portugal, Maria knew she wanted to be a marine biologist, and then how she evolved into doing marine microbiology in landlocked Austria. We chat about Maria's amazing research into the world of microplastics and how they're affecting the oceans and us. Maria also shares her insight into starting a career as a marine biologist. Without further ado, here's Maria Pinto. Maria, welcome to the podcast.
Thank you. Thanks for having me.
One of my very favorite questions to ask, I usually say for the end, but we're going to jump in right now. What is your favorite sea creature and why?
Oh, well, that is a difficult one.
I know, it always gets everybody.
Right off, like the first animal that comes into my head is a blue whale. I've always been fascinated by whales, since always. So one of the reasons is that there's not much known about them. So yeah, I'm going to stick to that. Maybe a blue whale.
Blue whales are pretty incredible.
Yeah.
Why isn't there much known about them? Just because they're difficult to track?
Yeah, they're difficult to track. There's not many of them, unfortunately. They have been, in the past, almost hunted to extinction. Mm-hmm. So now hunting blue whales in most of the world is forbidden, but their population is slowly recovering. So they're not many. They live in the open ocean. They don't come to coastal areas much, which makes it very difficult to study them.
That makes sense.
Yeah.
Now, is your love for whales why you wanted to become a marine biologist? What got you started?
Yeah, more or less. So I started, since I was very young that I wanted to become a marine biologist. It's all started with a show on TV.
Okay.
It was an Australian show called Ocean Girl.
Okay.
And the main character was a girl who could talk to a whale. And I already loved whales back then and the ocean. But in this show, there was also a woman who was a marine biologist and who was studying this whale. And for me, while watching the show, I thought, this is the job I want to have. They also worked in an underwater station, all made of glass, where you could see all the animals passing by. And I, back then, thought that it actually existed. Then it doesn't. But that's why I think that was the first seed implanted in my mind that I wanted to be a marine biologist. Even though I always loved the ocean. And so, yeah, so kind of related to whales.
I love it. There are underwater stations.
Yes.
I don't know if they're all glass, but
no,
definitely one.
I don't think so. Not in the, so this one was in the deep ocean. It was an
Oh,
all glass underwater marine station in the deep ocean.
man. Hollywood has a way of capturing our imaginations, doesn't it? I guess that's
Yes.
not Hollywood though. Whatever Australians' version of Hollywood is.
Yeah, exactly. It's great.
Fantastic. So you knew going into your undergrad that you wanted to become a marine biologist. Did you know that you wanted to go all the way to PhD at that point?
So no, actually, when I started, I studied biology. I started with just biology. I did know my intention was to further pursue marine biology, but I did not really know what that meant. I just knew that I wanted to study something in the ocean. That was pretty much all I knew back then. I didn't really know what. I wanted to do something that would be meaningful for helping ocean conservation, or even communities related to that have um, activities related to the ocean. So I'm from Portugal, which is a coastal country, and most of our economy of a lot, not most, but a lot of the Portuguese economies surrounds marine activities. And I was always very fascinated in understanding how these activities and the people who are involved in it kind of work together with the conservation of the ocean. It's a very complex it's a very complex thing because they don't always go hand in hand. And so I always knew I wanted to work in something related to that. And only in my master's did I start thinking about doing a PhD, because I didn't even really know what it meant to do a PhD when I started studying, when I entered university.
Okay.
That was a long answer for the question.
No, that's a great answer, because I think it's important to highlight that, you don't have to choose, oh, I will definitely do a PhD or not. You kind of evolve that way.
Yeah, no, definitely. And it was not obvious to me when I finished my master's if I was going to continue on with a PhD. So I wasn't certain when I applied.
Mm-hmm.
I'm happy I did, but even then I was not 100% sure, because you can work in ocean or even science or marine biology in a marine biology related field without necessarily being an academic and be working in a university. So I considered that option as well. I mean, I still consider that option.
Fair enough.
Yeah.
And I want to kind of come back to that in a second, but so did you get your master's immediately after your undergrad?
Yes.
Was it, where did you get your undergrad from? In Portugal, correct?
Yes, and also my master's in Lisbon, the Faculty of Science and Technology from the University of Lisbon.
Okay. Now,
and my master's as well. Yeah.
When you were completing your master's, were you doing a thesis for that?
Yeah. I did a master thesis, which was actually not really related to my PhD. So that's something people ask me, is how important is your master thesis in defining your career path, more or less. Mm-hmm. And my master thesis was with marine birds, and now I'm working with marine microbiology. So they are still marine, so in that way they are related, but in terms of the type of questions I'm asking, the methodology I'm using, they're completely unrelated to each other.
Right. The commonality is that it is science in the ocean.
Exactly.
What was your research on with marine birds?
I was studying a species, which was the Bulwer's petrel, in a colony in an island in the middle of the Atlantic. The reason why I chose why I wanted to do this master thesis is because it included a 2.5-month fieldwork trip in this deserted island, which had only one house. And this was the main reason for why I chose this thesis. And it was awesome. But what I was studying was these birds, they breed in this island. And once the babies hatch, they stay in the nest for a couple of days. No one really knew how many days. And after that, they go out to get food for the chick during the day and come back at night to feed them. And then they leave again before sunrise. And there's a lot of speculation on why they do that. And I was kind of trying to understand whether the time that they stay in the nest before they leave and the days that they come back to feed the chicks, if it was in any way related to the moon cycle. It was. Yeah.
Oh, really? How was it related?
So in nights of full moon, they would not return to the nest. And if the chicks hatched in nights of full moon, then the parents would stay longer before leaving the nest. One of the reasons for why that might happen is because first, there were a lot of seagulls in this island that ate these birds, even the adults. So one of the reasons is that because it's more light when it's full moon, that when they come back during full moon, that they might get eaten easier. Okay. The other one might be related to the diel migrations of zooplankton, because zooplankton, when it's full moon, they don't come to the surface so much to the surface layers, so they stay deeper in the ocean. So it might be that they just collect less food, and so they are less inclined to come back and stay longer foraging before they come back to feed their chicks.
It's amazing how nature is so interconnected.
Everything is interconnected. It is.
It continuously amazes me.
Yeah.
So you wanted to work on a deserted island for your master's. That's pretty awesome. What was the name of the island?
So it's the archipelago is Madeira.
Okay.
And it's a small island called Selvagens. Okay. And it's between the main island of Madeira and the Canary Islands. Okay. So it's right in between a tiny island there. That's part of this archipelago.
What was it like doing research on this island?
It was very interesting because there's only one house where that you share with all the people that are there. At some point, it was just me and one more person. And it's far from everything. So to reach this island from the main island, it took 24 hours with a boat.
Wow.
And you don't have internet and no phone connection. So the only connection we had to the outside world was a huge satellite phone. Or I had a satellite phone of my own that I brought from mainland. And to be able to send a message or call, I had to run up to the top of the island to get a signal. So that was very interesting. It was a whole new experience.
And this is 2 months like this?
Yes.
So did you have to bring all your food and bedding and everything for 2 months?
Yeah. So they have every 3 weeks, it might vary depending on the weather conditions, but usually every 3 weeks they would bring new people and bring new food, and the old people would leave. I was the only one who stayed there for 2 exchanges. So every time someone came, the people who were there before left, and they would always bring food with them.
Okay.
There was also a dog. Made a lot of company.
There you go. One solid companion for your whole trip.
Yes.
Wow, that's a really incredible experience. And I mean, you got to live on a deserted island. So you
That's
wrap
true.
up your PhD, and what made you decide to pursue, or excuse me, you wrapped up your master's. What made you decide to pursue your PhD? Hey, Kara here. I hear it all the time. How do I become a marine biologist? Or my niece wants to help the ocean. Where does she even start? I hear from students, yes, and also nurses, HR professionals, and other mid career folks who wonder if they could still make their dream of working with sea turtles or sharks come true, wondering if it's too late to answer the ocean's call. Here's what I've learned after 20 years in the field and hundreds of interviews. There's no straight line, no magic degree, and no gatekeeper. You create the path forward. If this sounds overwhelming and vague, I've created 2 tools to help you stop wondering what if and start moving forward with clarity and purpose. The first is my free guide, Be a Marine Biologist Without the Degree. Over 1,000 people have already downloaded this guide and taken their first step towards ocean impact. Inside, you'll find 7 concrete, doable actions to help you get started, whether you're just exploring or ready to make a change. Then there's the Ocean Blueprint. This is a 30-day self-paced course that helps you build your unique path into ocean science and conservation without quitting your job or going back to school. Inside the Ocean Blueprint, you'll get daily prompts to explore your interests, skills, and next steps, a structure that turns overwhelm into real momentum, and a bonus section to root your work into ocean connection. You don't have to wait for a degree, a perfect plan, or permission. Whether you're wading in or ready to take the deep dive, these tools are here to help you move from dreaming to doing. The ocean called. Are you ready to answer? Links in the show notes and on my website, karagracemuzia.com. I can't wait to see the waves you'll make.
You mean my topic, the one I'm doing now?
Or even just in general.
Oh,
like,
in general.
What made you decide to continue your education?
Good question. So,
But, I mean, was it your research topic? Was it something that you wanted to look more into?
Yes, my research topic it was a part of it. I think for that to kind of reach the reason for why I decided to do the PhD, I have to give a bit of a backstory. So when I finished writing my master thesis, I had to wait for a couple of months until I could present it in front of a jury and defend it. Mm-hmm. And during that time, I came to Austria for 2 months because my boyfriend is Austrian and he was here, and I decided to visit him. And because I didn't want to stay 2 months without doing anything, I contacted my now supervisor, who is the head of this department in Vienna, if I could do an internship in his lab. Because even though I really liked marine birds, and I still do, I realized that that was not really the type of research I would like to pursue. So I wanted to still do marine science, but I wanted to explore other fields before I jumped into a PhD or decided to do a PhD. And so I asked my now supervisor if I could do this internship in the lab where I am now, which focuses on deep sea microbiology. And it's something I thought this is fascinating, and I wanted to know what kind of research you can do in this field. And everything went well, and I ended up getting a contract to stay there for 1 year after that, as helping other people, helping other PhDs. And during this time, my supervisor said, if there's something in this field of marine microbiology that you would like to work on your PhD, we can write a project together and apply for grants. Okay. And so this was when then I had to decide whether I wanted to do a PhD or not. And and for that, and what made me decide was that I found this topic, which is what I am working on, that really, really interests me. And I wrote the project on that. And because I ended up getting the grant, I decided, okay, then I will really pursue a PhD, because this topic really, really interests me. And it's something I really see myself working for now, at least now 3 or 4 years. Awesome. So that's the long story.
No, that's fantastic. Before we get into your research, and I definitely want to chat quite a bit about it, because I find your research really fascinating, and it's a hugely important issue that you're looking into in our oceans. But before we get into that, 2 questions for you. Did you know your lab or professor before you reached out, or was it just a cold email or phone call that you're like, hey, I'm here and I would like to work in your lab?
I didn't know him before, but so Austria is a landlocked country. And this is, I think, the only marine biology department in the whole country.
Okay.
I think solely marine. And I was wondering, so I Googled marine biology in Vienna, and I found this department. And then I before sending an email, I decided to research on my supervisor. And I saw that he was good on what he was doing. So I said, yeah, this is cool. But I didn't know him before looking for it. No.
I love that. I love that Google got involved too.
Yes, always.
Always. No, it's something that I've been hearing for quite a few people, and I love it. And it's something I've been kind of chatting a lot about. Is like, don't be afraid to reach out. If somebody's doing something you're interested in, talk to them. Just reach out. Worst case scenario, they say go away because I'm busy. But like, you just never know where connections may lead. So it's absolutely worth reaching out to.
Definitely. I think that's even how you may usually get the best opportunities.
Absolutely. And the second question I wanted to ask you before we dove into your research, was your internship paid?
Those 2 months I was there? No. It was voluntarily based.
Okay.
Because I had no experience in this field. So it was just literally me going there and asking if I just wanted to learn. And I just asked if I could be there and help anyone that needed me. So I didn't really have the qualifications for a paid internship, I think, at that point.
Okay.
But then I learned fast, I think, in those 2 months, because I was helping and working with a lot of people in the lab.
Okay. And then that's how you were able to earn your place and decided to move to dive in further. Okay. No, it's also something that's been coming up. People are asking about internships and if there's any paid out there. And it's always an interesting question to ask, to see who's had paid internships or not.
Have you met a lot of people that had paid internships in labs, research labs?
Not lately. No.
Yeah, no, I don't think.
Okay. So your research, what did you write your grant about, and why was it so interesting to you?
So my grant is very simplifying, is about the interaction between microbes, mainly bacteria, in the ocean, and plastic pollution in the ocean. And what interests me was that I wanted to, my one condition to myself to pursue a PhD was that I wanted to do something on something that I felt like my research can help an immediate crisis, not crisis, but like I wanted to feel like I can somehow, my research might in a very, very small way help some of the big issues that the oceans face today. And there was, you started back then, it was the time when there were a lot of talk, there still is now, but the boom of talking about the problem of plastic pollution in the ocean and how it's affecting the ecosystems. And during these internship, while I was diving into the microbiology, marine microbiology world, I realized that these little guys can do everything. They can find ways to survive in the most incredible of environments, most extreme environments. They can degrade the most weirdest compounds. So I started thinking, well, maybe what about plastic? Don't they degrade that? I mean, plastic is mostly made out of oil or natural gas, so it's all organic. And I started digging a bit into the research, and I did find that there were some studies done in the soil on fungi and bacteria that could degrade plastic in the soil. But to my surprise, there was nothing in the ocean. So no studies on how whether or not there are organisms in the ocean that can degrade plastic. Since then, this has changed. So I was not the only one with this idea, but this was what kind of made me why I decided to write a grant on this topic.
Great. So just to highlight, I think most of my listeners understand that plastics in the ocean is an issue, but it really is a huge issue. One of the main concerns about plastics in the ocean is the effects on wildlife when it's ingested. So there's like chemical leaching and, false feeling of feeling full. And it's like happening in birds and whales. And I even saw recently a graphic with like 3-week-old sea turtle hatchlings having tiny bits of microplastic in them.
Yeah, it's really sad.
Yeah. So your research takes a microscope to the microplastics, literally. And I think that's amazing.
Yes. The truth is, there's so much we don't know that it's crazy. The amount that we know of how the plastics impact the ecosystems, especially marine, because the ocean is huge. You have a whole water column from the surface to the sediments that is unsampled, and that we have no idea what is happening there, how many plastics are there, which ones sink more. I mean, this we know, but we don't know exactly how many stay in the water column. So there's so much we don't know. How much is degraded, how much is turned into micro or nanoplastics, if they leach additives that are even potentially more dangerous for the environment and our health even than the physical effects of there's just way too much that we don't know. So this is extremely fascinating field right now. There's a lot of interesting things being discovered every month, and it's quite exciting in the scientifically wise, scary in an environmental way.
And yeah, scientifically, there's lots of questions. And so therefore you're like, oh, well, there's lots of research, but absolutely environmentally and as a citizen of the planet, you're kind of going, what's happening?
Yeah.
So your research, you cover literally the microbe communities. And I didn't realize that there could be specific, depending on what type of plastic it is, it could have a different bacteria that's attracted to it or degrades it. Could you explain a little bit more about that?
Yeah. So different plastics have different molecular compositions. By different plastics, I mean, many plastic materials like water bottles or packaging have this triangle made of arrows with a number or letters in the middle. Mm-hmm. So this symbolizes the type of plastic that this material is, which type of plastic the plastic is. There's two most produced and most used for it, which is polyethylene and polypropylene. And those are mostly made of carbon and hydrogens. Well, this doesn't really matter, but they have a different molecular composition between them and from all other types of plastic. And besides that, different plastic types also have different additives. So additives are compounds that are added during the manufacturing of plastic products to increase their performance, be it to increase their flexibility, durability, to prevent them from breaking down, to make them more durable. So these are all compounds. There are a huge variety of them that are added to these plastics to evaluate their, to increase their performance. And we don't really know how microorganisms interact with both different plastic molecular compositions, but also how they react to different additives. And because so we do know now that under certain conditions and in certain situations, there are different bacteria colonizing different plastics. And we don't exactly know why, but one of the possibilities is the additives that are in the plastic. So different additives might attract different bacteria. But there's other possibilities too. Might be simply because of some are more smooth than others. They prefer to attach to less smooth surfaces, or there's a lot of physical chemical properties of the plastic that might influence this preference of some bacteria. It's rather complex, actually. It's not, so we still don't really know, but it's true. In some situations, there are specific bacteria that prefer specific plastics.
Okay, that's interesting. And it's something that we can see. We may not be able to see like the individual bacteria, but almost pretty much anything that goes into the marine environment, there's always some sort of growth on it. We call it epibiota, or like a biofilm, right? That occurs. And that is what the bacteria is that is attracted to the plastic. Is that correct?
The biofilm, you mean?
Mm-hmm. Yes.
Yeah, so there's biofilm forming bacteria anyway. So any surface you throw in the water will be covered by bacteria after a while.
Right.
And plastic is just another surface for the bacteria. It's just that we don't know. It's just that we know that different plastics now attract different bacteria. Why that is, we don't really know. But yes, even ropes, anything you throw in the water, at some point bacteria will attach to it, because there's bacteria that just simply like to attach to stuff.
Right.
Being attached to a surface can give them be very beneficial for a lot of species.
Can this bacteria break down these plastics in the ocean? I mean, you talk about there's biodegradable plastics, but typically anything that's labeled biodegradable doesn't usually break down in the marine environment. It requires much higher heat temperatures.
Yes, that's another one we don't know. That's a part of my project. So part of my project is to try to understand whether there are bacteria that could potentially degrade the plastic. So the tricky thing is, plastic is very durable and is very resistant to biodegradation. And even if there would be bacteria that have all the machinery, so they could produce all those enzymes and compounds that would allow them to biodegrade the plastic, we don't know if they would do that in the environment when they have so much other potential food sources that are easier to access than plastic. So this is something a lot of people are trying now to figure out, is whether these plastics are really degraded by bacteria, or if they are simply breaking down to microplastics. Because one thing is to be biodegraded, so basically their molecular structure, the carbon within the plastic is really, the molecules are really taken down and they are not plastic anymore. or if they just break apart into smaller plastic pieces. So this is really under debate now within the community, whether the plastics are being degraded or if they're just simply being fragmented into smaller and smaller and smaller pieces. So to answer your question, whether there are bacteria that can degrade it, there's indication that there are bacteria that under certain conditions can degrade them. Whether they do this in the environment, we still don't know.
Now, when you go out and where are you sampling from? You mentioned you're in a landlocked country, but you're doing marine microplastics. So where do you get your samples, and how is that conducted? How's your research conducted? For
different projects, I sampled in different places. For one of the projects, I did all of the sampling and all my experience in all my experiments in the North Adriatic, which is between Italy and Croatia. So it's a sea which is north of the Mediterranean, and it's so between Italy and Croatia. It's a 5-6 hour drive from here. So even though it's a landlocked country, Austria is still relatively small, so you can reach the sea still in like 5 to 6 hour drive. So I did a lot of work in this institute in Croatia with whom we have a partnership. And I was there for the first 2 years of my PhD, maybe 3 to 4 times a year for 2 weeks. And that's when I got most of my samples and where I conducted most of my experiments. So I also have experiments in the lab here in Vienna going on. For instance, the biodegradation experiments, where I try to understand if there's bacteria that can degrade the plastic. These, I brought samples from Croatia, but since then I can conduct all my experiments in the lab. And then for another part of my studies, I went on 2 research cruises, one in the Pacific and one in the North Atlantic, to collect plastic samples from the environment as well.
How long were your research cruises?
So the one in the Pacific was pretty long, was 5 weeks, because we went from Auckland, New Zealand to Alaska. And so it was a pretty long stretch, and it took 5 weeks. And the second one in the North Atlantic was, I think, 12 days, something, a bit less than 2 weeks.
Okay. Now, and you were sampling for plastics did you just go to predetermined spots, or just along the whole cruise, each cruise, were you taking samples?
Along the whole cruise, we had, so the cruise had already predefined sampling locations, so places where they would stop to do their sampling, and I could tow my net in these spots as well to collect my samples. And it was along the whole transect, more or less. But surprisingly, in the Pacific, I collected plastics only close to the gyre, the North Pacific gyre. In the South Pacific, I didn't collect any samples, but also I had a net which was not ideal for the collection. But I was surprised, I have to say, which was good to see that there's still places where it's not completely full of plastic.
Yeah, that was one of my questions, is did you get any samples that weren't full of plastic bits? Yeah. Why was your net not ideal? Were the holes kind of big? Like, could you have missed nanoplastics?
I didn't look for nanoplastics. I only looked for, so that's another thing. I don't know I only looked for plastics that I could see under the dissection microscope. So nanoplastics are not part of it. And also the net size was 500 micrometers. So it's pretty big microplastic.
Right.
And
so you could see that with your naked eye. It's not like I could see it.
Yes.
Yeah.
because I need to extract DNA from them. So I need quite a lot of material. So I would not be interested in nanoplastics that I couldn't see, for instance, for my specific research question, because I need to collect the pieces and I need to be able to manipulate them to transfer them from tubes to tubes. And for that, I need to be able to see it.
I think it's really interesting that you extract DNA from plastics, because typically you think of DNA as like a living creature thing and not a chemical compound thing. How do you do that?
I mean, the DNA is from the bacteria that are living attached to the plastic, not from the plastic itself.
Gotcha. Okay.
Yeah, no. No,
Like,
I mean, because I'm assuming that sorry, I did not explain myself very well, but the plastics have this biofilm layer.
right.
Usually the longer they are in the sea, the thicker it is. And I extract the DNA. When I say the DNA from the plastic, is from everything that is attached to it, basically.
Gotcha. How do you extract DNA from biofilm then?
It's a kit. It's a protocol. We actually, me and a colleague, we tested different methods to extract DNA from the biofilm from plastics. And we found the best one. We modified it a bit, and now that's the one I use for my research. But it's basically a protocol that's kind of already established. It's not very different from extracting DNA from tissue or any kind of live material.
Gotcha.
It's pretty similar.
Okay. You got a little experimentation within your experiment. I like it.
Yeah. Methodology. Development.
So in the middle of all of your research and about birds and plastics, you decided to start a YouTube channel, which is how I found you. What inspired you to start your own YouTube channel?
So I started my YouTube channel already, I think, in the second year of my PhD.
Okay.
And I think it was something that was just slowly creeping in my mind for a very long time. I have a lot of friends who never worked in academia or any science related field. And I always heard them asking me, I always realized how much people who don't work in the field don't really understand what science is and how it works. So there's this very, I think, romanticized sometimes idea of what science is, or just generally how things work behind this field and what scientists do. And I always thought it would be interesting to somehow find a way to show the behind the scenes of everything. And first, I just thought I would like to go and talk to schools. And when I was already in Vienna, so I contacted some institutions, but they all asked if I could do it in German. And my German still is not that great that I could talk to kids. So I couldn't do that here. And and then I was talking with my boyfriend about it, and he said, "Why don't you start a YouTube channel?" I don't know if he was joking, but I started it.
You took him seriously.
I took him seriously. Exactly. So that that's actually maybe not a bad idea. And so that's how it started. It kind of diverged to something different than what I'd envisioned in the beginning. But I don't mind. I'm still enjoying it very much.
What was your initial vision for it? Just truly the behind the scenes of how your research is conducted, and then what has it evolved into?
So my initial was, which I try to do and I still do sometimes, is more this vlog type video where I basically film what I do in a day in terms of work in the lab and at work. That I work a lot also at the computer and the lab work. There's a lot of lab work involved and statistics and all that. But I realized that vlogging while working in the lab is really difficult for several reasons. One of them is that there's always people around, and not everyone really likes the hovering and the presence of someone always filming something. So that's something that I have to respect.
They don't want a camera in their face while they're trying to work their database.
No. Surprising, right?
Shocking.
Yeah. So yes, and so I also don't feel comfortable myself talking to a camera. I mean, this is just a personal thing. I just don't feel comfortable talking with other people around. And so all of that made me do this type of vlogging video very difficult. And also because when I'm in the lab, it's very difficult to focus on both things. And if I'm doing an experiment, I have to be 100% focused on what I am doing. So in the end, it's quite difficult to do that. So my initial idea, it didn't take me very long to realize that it's not very feasible. And so it kind of evolved to me sitting and talking to the camera and talking about my experiences, and instead of maybe showing my day-to-day life, even though when I go on field work, I still do that, because I think field work is such a different thing from everything else, like going on a research cruise or going on a field trip to collect plastic in the sea. So when I go, I still try to find a way to kind of make those videos, but this everyday vlogging is not possible.
Fair enough. I do love the videos that you've posted. I mean, you give a behind the scenes of like what marine biology is really like. You've taken, like you mentioned, out into the field, why you chose universities. I mean, you've got a lot of really great content up there.
Thank you.
What is one of your favorite videos that if people were like, oh, you have a YouTube channel, you would be like, yes, and this is the one that you should watch first? Is there one?
Well, it really depends on, so there's one video that I'm very proud of because but it's the one that I'm sure people care less, because it's one of the videos with less views in my channel. But I'm more proud of because it took me a long time to do, and I had a lot of fun doing it. And it's just one, but it's not about marine biology. And I think that's why I think people who watch my channel are more people who are interested in being marine biologists and in the field of marine biology as a job, rather than really ocean facts, like learning about facts. So the video I'm talking about is one where, I don't remember the name, but it's one where it was from last year's around Christmas time. I baked cookies in the shape of marine animals, and then I made animations with those cookies while explaining facts about the animals which the cookies were shaped after. And I just had so much fun doing that video, but it also took me so long that it's my favorite video, I think, on my channel, but it's the ones that has less views. But so if someone would ask me to watch a video on my channel, it wouldn't be that one, just because I know probably it's not representative of what people want to see.
I don't know. I think I'm gonna go watch that video now. That sounds pretty awesome.
Yeah, it's funny. So I think it's one of the funniest because it's so random. But
yeah.
it's maybe the one that has more views because it kind of explains everything about me, I think, which is called How I Became a Marine Biologist. It's the one that has by far the most views of all my videos. And it kind of explains my journey, and it's a good an opener to the channel, I think, explaining why I maybe start a channel and where I come from and all that. So yeah, maybe that one. I think people like that one, and it's very interesting to me. That's when I started realizing how YouTube really works, because it was very interesting to me that this was one of those videos that I almost didn't upload because I thought no one would care. But then you realize that people want to learn from stories, from personal stories, including myself, actually. I just didn't never put that into thought. I thought no one would care about how I became a marine biologist, but a lot of people did, and it's
people
cool.
love stories. And it's funny how, you know, sometimes you don't think that your stories are included in that until somebody else is like, no, that's really interesting. I want to know more.
Exactly. Yeah, definitely. Yeah, exactly. Yeah, it's true.
So post PhD, how much longer do you have in your PhD? Is there an end in sight, or are you continuing on?
My imaginary limit is somewhere the first half of next year. I would like to finish.
Okay, that's exciting. The first half of 2020.
Yes.
All right.
But I don't want to sign on that. I already said last year that I was going to finish this year, so I don't want to sign on that.
That's a very common phenomenon with PhDs. I have friends that have dragged on for quite some time. Like, it's next year. It's this semester. I lied. It's next year.
Yes.
Fair enough. So post PhD, do you have any ideas of what you would like to do? You want to go back, or do you want to try to find a job with whales?
No, I don't think so. I don't really know. I think if I were to continue in the academic world, I would pursue marine microbiology. I really enjoy it as a research field. So as something from a scientific perspective, I love it. Because there's so much you can do, so much questions. They are responsible for pretty much everything in the world. They are the base of everything, and they impact and influence so much of the world's ecosystems. And I think that's really fascinating. So if I would go on in science, I would think I would pursue that. The other option is to not pursue a career in academia and do something else, which is always on the table. Science communication being one of the options, definitely.
Yeah, you're great at it. Got a channel to prove it.
Thank you. I need to increase. So if I would do that, the first thing is to improve my writing skills in English because, it's not my first language, and now my channel is in English, and I would like to improve it. I still feel like that needs some improvement.
I think you sound pretty great, but we're always our own worst critic, right?
Yeah, yes. True.
All right, I have a couple more questions before we wrap up here. What is your favorite field story or stories to tell? And you've had quite a lot of field time. You've done research cruises, you lived on a deserted island. I mean, you got quite a bit. So it could be the best day, the most amazing things happened in the field, everything went right, you saw a really incredible phenomenon that you never thought you would, or it could be the worst day where everything went wrong and now it's a really great story to tell, because we all have those days.
Yes. Let me think. There's a lot of stories. So definitely the whole being in a deserted island is a story by itself. But if I have to think of a day, well, I don't know if it's interesting, but a funny one, funny not for me back then, but now it's funny. It was in my second research cruise. Was in the North Atlantic, and I thought that I didn't get seasick because my first research cruise.
I like how you started that. I thought I didn't get seasick.
Yeah,
I was wrong.
You already know where. So, but the thing is, in my first research cruise, which was the longest one, it wasn't a very large ship, research vessel. So I didn't.
When you say that, how big was it? Because
I get 100 meters long, and so we were 40 scientists and 30 crew. So it's very stable. So even if the sea is big, you don't feel the waves so much. So I came out of that cruise very happy, thinking, well, I don't get seasick ever. But then on my second cruise, it was in the North Atlantic, and the ship was much smaller. So it was less than half the size. And in the first day, when you have to try, so there is always, in the beginning of a cruise, there is always like a security introduction.
Oh, yeah, like a briefing where they get everybody together and they're like, these are the do's and don'ts, and here's where all the safety equipment is.
Exactly. And there's also there was also in this cruise a part where you have to try on a suit, which is this suit that if the boat is sinking, you have to put it on so that it's basically, you look like an astronaut, like huge, like, or the Michelin, you know, this tire,
the Michelin
thing,
man.
like the Michelin man. It's very thick, like neoprene suit, huge, and very kind of annoying to put on because it's all over the place. But we were having this briefing in the back of the ship where it smelled like oil, and there was this the fume was coming out, and everyone was super silent. It was dark, so you couldn't see. It was at night. There was no horizon anymore where you could fix your eyes, and everyone was trying on this suit. So the guy was talking, and everyone was trying on this suit, and no one was talking, which was strange. Like, we were generally a talking group, and no one was talking, and everyone was about to just be very, very sick. And at some point the guy said, okay, the briefing is done. Everyone just dropped their suits and ran. There was like a run to the toilet. It was like almost a competition who gets there first.
Oh, man. In case of emergency, I will figure out this safety suit until I'm getting away from it.
It was, I mean, now we laugh about it looking back at how chaotic a bit it was, like everyone just trying to control themselves. But yeah, it was just one of those funny stories that you look back and it wasn't funny at the time, but, and it happens very often.
Right.
So
there's something about the smell of diesel that just,
oh man,
it gets me too. I get it.
That's for me. That's the worst thing in a ship for me, is the smell of the fuel. The fuel. It's a killer for me.
Mm-hmm. That's my weak point as well. I understand. Do you have any advice for aspiring marine biologists, or any advice that they should ignore?
If you are starting a PhD, or if you are looking for a PhD, I would say more important than your topic is your supervisor. I'm lucky with my supervisor, but I know a lot of people who are not so lucky, and if you might have the most amazing topic, but if you don't have a good supervisor or someone who's really complicated to deal with, then it might destroy your topic, even if it's the most amazing thing ever. So choose wisely when at the supervisor into your PhD. If just, going more back, if you're starting marine biology, engage with people. Try to, if you are now just starting to study marine biology, try to see what kind of research is being done in the field where you are studying. Maybe try to volunteer here and there, because I think it will really help you have a grasp of how things actually happen behind the scenes, and will also kind of help you decide which direction you would like to go in the future.
Great advice. With the PhD and finding your advisor, do you have any recommendations of how to do that? I mean, you kind of cold reached out and interned, but if you had a terrible internship that was 2 months, like, you can't always do that. So is there a way to, do you just take them out for coffee? Do you chat with them on the phone? Like, how does that work?
Yeah, that's a tough one. If you have the opportunity of working a bit before starting a PhD somewhere, do it. If not, probably that's not an option most of the times. Try to do a bit of investigation, contact people who have worked there before, even though this might be also tricky because you never know what kind of connections that people have or not. But let's say if you're doing a master's and you will continue working during your PhD more or less in the same kind of topic, it's probable that you know someone who at least knows someone who has heard something about this person.
It's true.
So ask around, ask every contact you know whether they either know someone in this lab where you are applying to, or if they know the supervisor himself. And of course, talk to the supervisor prior as well, but that might be not, so just talking to someone in 1 or 2 times as it will really not tell you much how the person will be as a supervisor.
Right.
Well, it tells you whether you like them or not firsthand, but that might change a lot during a PhD time. So just try to research, ask around. Probably not on Google. That's not something you would find online. It's really just about, I think, using the connections you have in the field, even if it's not a directly related field. People know each other usually. So
that's true. And people are usually pretty forthcoming with their experiences, especially if they're no longer working with that person. They tend to be a little bit more candid with their responses.
Yes. Yeah, and I really stress how important that is, because I know so people that fell out of love from science and from marine biology because of bad experiences during their PhD, because of their supervisor, that it's kind of sad that one person can influence one, but it's how it is, can influence your decision so much.
I always like to end with an ask for the audience, and we chatted a little bit before the podcast. What would you like for the audience to take away from this episode and go forth into the world and do?
First thing is, do what you feel is right and for you, and that you are passionate about. If you pursue marine biology, don't pursue something that you're enthusiastic about and that you are passionate about, because it can be a lot of hard work. And if it's something you are passionate about, it will be hard work that you will not mind doing. Mm-hmm. So asking yourself if this is something you imagine yourself doing for the next years. If the answer is no, then maybe think again. And if it's yes, then go for it. And yeah, enjoy the ride. I think that's pretty much it.
I like it. I kind of want to tack on to that. Just, if you do decide to pursue something in marine biology and maybe you decide you don't like it, like in your case, you enjoyed seabirds, but you realized it wasn't something you wanted to pursue. Don't be afraid to evolve.
No, and don't be afraid. There will be a lot of people saying there's a lot this preconceived idea that once you make a decision, you cannot deviate from it. Mm-hmm. And I really don't agree with that. I think people evolve and people change, and if you have the opportunity of following what you feel is right for you at that moment, then just do it. Absolutely. Of course, some people have other conditionings, but provided that you are free kind of to choose what you can do, then I think just doing something because it's what expected, or just because it's what you're supposed to do, don't do it if it doesn't feel right for you, especially if it's regarding science, because science is something you have to do really if you are passionate.
Thank you so much, Maria. So if listeners want to connect with you more, where can they find you?
So you can follow me in my Instagram at maria.candme. So there's only one A between C and me, no two. You can also find me on Twitter at mcmariac, or you can check out my YouTube channel, which is called C and Me Marine Stuff with Maria.
I love it. I will put a link to all of this in the show notes over at marinebio.life/Maria.
Well, thank you so much.
Absolutely. Well, thank you for being on. This is an awesome chat. I really enjoyed it.
Thank you, Kara, for having me. It was really nice.
This episode is brought to you by the Safina Center. Through best-selling and award-winning books, films, and photography, the Safina Center is making a case for life on Earth. Founded by Carl Safina, award-winning author and ecologist in 2003, the Safina Center aims to inspire and engage to devote time and energies to conservation of wild things and wild places. If you haven't already, check out episode 22 of this podcast. On it, I chat with Carl Safina about his lifetime of conservation work and how the Safina Center came to be. I've personally been inspired by Carl and the work of the Safina Center. Their work brings wildlife in all its forms into our homes and hearts and makes the case for preserving this beautiful planet of ours. For more information, please visit safinacenter.org. Hey, do you want to help the oceans? Have you considered a career in marine biology, but maybe just aren't sure where to start? Head on over to my website, marinebio.life, and subscribe to my newsletter. When you subscribe, you'll receive a free PDF download where you'll learn the 7 steps to becoming a marine biologist without the degree. Thank you for listening to today's show. I'd love to hear any insight you've gleaned. Leave a comment in the show notes or send me an email over at marinebio.life. If you enjoyed this episode, leave a review and, of course, share with your friends. If you want more resources for ocean news, including conservation topics and careers, plus personal insight from me that I just don't share anywhere else, join me at marinebio.life and sign up for email updates. Keep after your dreams and making waves in your community. One person can make a difference. Thank you so much for listening, and I'll catch you next time on the So You Want to Be a Marine Biologist podcast.